All right. All right, you guys, I'm going to go ahead and share my iPad screen and let you guys kind of guide what we go over. So you can ask a question in chat, or you can unmute yourself and ask a question. Either way is completely fine. But this is review session to help you get ready for the test. So anything I'm going over that you don't understand, please ask, because we need to make sure you understand it before tomorrow. You guys can take the exam anytime you want tomorrow. It's 90 minutes once you start. So make sure you start before 10 p.m. But if you want to start tomorrow morning, you can. If you want to start tonight at 12:01, right after midnight, you can do that as well. But once you start, you got your 90 minutes and then you're done. So make sure you do that. Open book, open note, we know all that stuff. No electronic resources, no calculators, and no access to any websites. Okay. Questions? Let me pull up the chat. Go ahead.
Can you go over, it's number 2 on exam 1, fall 2018.
Yep. Okay, so that is this problem, x cosine of 4x.
Yeah.
And that's actually the problem I saw that said that I was saying, if you see integration of parts, which we may not know what it is yet, that is not one we know how to do yet. Okay. So at that semester, we had gotten further before the first exam. Okay. So sorry. Everybody should be comfortable if I changed it to this. Is everybody okay doing that problem? Okay. But
yeah.
X cosine 4x, we do not know how to do that yet. All right. Sorry. Other questions?
This isn't necessarily math, so
Go
sorry,
ahead.
but could you go over how we input the stuff in WebAssign again that you did yesterday?
For the volume problems?
Yeah, like how you would write the F
Yeah,
X
so
and
like
Y.
There's a couple of, most of the WebAssign problems, most of the problems are very straightforward. It's just, like you did with integrals before. We just haven't had any volume problems on WebAssign yet because all of the publisher written questions, you had to evaluate them, and the only thing it checked was the final answer. And so that's the reason I have not given any homework on WebAssign for volume. You will have a couple questions where you have to evaluate it and you just put a final answer. But the ones that I think you're talking about are, it would give a problem like this. It would say, okay, consider the region, bounded by whatever. And then it's going to have, so there will be 2 problem setups like this, where it'll have a part A and part B and a part C. And so part A, and it might mix up this order, so I don't know, but it'll say set up integral for the area, and it'll say it in a more formal way. And then part B will be like set up integral for volume when it's revolved around something. And yeah, Nick, that will be the next question we do. I see this question in chat. Volume when revolved about whatever. Okay, and C will be the same thing. Like x equals 10 or something like that. Okay, so what you do, or what it's going to do, is it's going to give you this. It's going to say the integral should look like either f of x dx from a to b, and it just tells you that. So it just says, okay, it's either going to be this or this. And then same thing down here, it's going to say it's either this or this. And it's not like you pick one. It's just saying, okay, it's going to be one of those 2, and you decide, I guess. And then what it asks for is 4 answers related to that. So it's going to ask what's A, and it's going to give you a box for A, and what's B, and give you a box for B. It's going to say, okay, f of x or f of y. What is that? And then it's going to say dx or dy. And it's going to have a box for that. And then same down here, A, B, and then f of x or f of y. And then dx or dy, and then C is going to be basically the same thing, just a different line you're revolving around. And so this is just a way, the reason it's set up this way, I think it's the best way for you to be able to enter it in and get credit for being able to set it up and not have to evaluate, which is like what a lot of the homework is talking about. And so these problems are worth quite a bit. And they're intended to be as easy as possible for you to set it up right. So, and I know that because I actually wrote the question. So I'm really want them so they're easy for you to do. So let's say that not the problems themselves, but entering in should be easy to do. So let's say that you decided the area is the integral from 4 to 7 of x squared minus 3x minus 9 dx. And then let's say that this one you decided was 2 pi integral from 4 to 7 again, and then 10 minus x, and then, I don't know, x squared minus 3x minus 9 or whatever, dx. I'm making those up. So, but let's say those are your answers like you would normally have. Does that make sense to everybody? And again, please ask if you're unclear. So if this is what you would have, that you would have written, as the answer. Yeah, so the question in chat is, do you get multiple attempts? No, it's a test. So, I mean, you can definitely change your answer, but you submit the test all at once and it grades it at the end. So it's not like it says, hey, you're wrong, and you can change it then. Okay, so if this is your answer, what you would, yeah, no problem. You would type in 4 for A, 7 for B, and remember it's like A is on the bottom, B is on the top. And then in here, you would type x squared minus 3x minus 9. And that's set up where you can use like the math pad. It'll let you do exponents and all that like you did with all the WebAssign that we've already been doing. Does that make sense to everybody? Okay, and you don't like type f of x or f of y. It understands that if you're typing that, you clearly want f of x. So you're putting that, and then you type in not dy probably, dx there. So you're just typing either dx or dy on that one. Here you type what actually goes in the integral. Here you type what it is, whether it's dx or dy. Down here, same thing. The only thing you got to watch is that the 2 pi needs to go in there. And I actually put a warning message about that. I'm like, make sure you put pi or 2 pi in this answer and, use parentheses correct way or something like that. So you put the 2 pi, you put 10 minus x, you put x squared minus 3x minus 9, and then, you just make sure it's grouped right, and it is, and then you put dx here. And that's it. And this is just like an equation editor thing where just like you're doing on integrals or something like that. And I think that's an easy way for you guys to type it into WebAssign. I hope. I'm not trying to make it hard. I'm trying to make it so that it's easy for you to show you know what you're doing. Does that make sense to everybody? All right.
Yeah.
Okay, cool. All right, any questions about how to format? And then there'll be a part C that's the same basic thing.
I have a question about the scratch paper.
Sure.
So, well, 2 questions. For this one, do you want us to like put, say for this problem, we put number 1, section A. Do you want us to section off our scratch work? Like so
you
we
don't
can
have to do that.
Okay.
But you should put, if this is problem 7 should have your sketch of the region and whatever work you're doing.
Okay.
You don't have to have every little thing on the scrap paper. Like if something you type in and you're clearly getting this just by looking at the picture, completely fine if you didn't need to write that out, okay? Yeah, do it so it's going to help you. It's just, especially more on the integrals, we need to see it. And on this, we should see a picture of the region probably.
Okay, and also, are we allowed more than 1 piece of paper or no?
Of course, please. Use as much paper as you want. Yep.
Okay.
And then when you submit it, you're going to have to mess with CrowdMark. I think the easiest thing for CrowdMark is if you have like a free cam scanner app and you can like upload it as one PDF. So if you can do that, that's fine. If you'd rather upload it as 10 different pictures, that's fine too. Just we need to be able to see everything you've done. But you upload it how you want, and that's after the time limit's up. Okay, so like after you're done with the test and you've submitted it, then you do the CrowdMark stuff. So there's no like time limit on that. But you can't have submitted that 4 hours later. Like the timestamp needs to be, within 10 or 15 minutes of when you submitted the test. Does that make sense, everybody? Yeah, so Alex, somebody in chat's asking, can you take it anytime? Yes, you can take it at any time. You could start as early as 12:01 a.m. You should start no later than 10 p.m. It'll time you 90 minutes when you start. So you have to finish within those 90 minutes. But other than that, you can decide when to start. But if you choose to start at 9 a.m., then you're done by 10:30 a.m. You don't get to take it again or something like that. Okay? And it's going to be different for every student. So if, just perfectly honest, if you have a friend who takes it at 8 in the morning and you say, hey, what's on it? It's going to be close, but it's not going to be exactly the same as that person's test. Okay? All right. Other questions? All right. So Nick in the chat asked, could we do a U sub like this? And I think I'm actually going to take your integral, if that's good, Nick, and do this one. So the integral is x to the 5th times x cubed minus 5 to the 3/2 dx. And this is probably one of the most challenging types of integrals we've had, which is good. Just don't panic if you look at this. They're not all quite this hard, but this is something that you want to know how to do for the exam. So let's look at the problem. So we should start this by doing u equals x to the 3rd minus 5, and maybe not even knowing for sure that that's going to work. But given what we've done at this stage, that's the only thing really that we could even attempt here. I don't know that there's much else that would make sense to try here. So if you let u equal x to the 3rd minus 5, du is then 3x squared dx, which actually doesn't immediately seem like it's going to work, and it turns out it does, and let's see how. But we don't have a whole lot that we can try at this stage on this problem. So what I need to do is I need to create du at the end of the problem. So I need an x squared here. Well, I don't have x squared, but I've got x to the 5th. So I can split the x to the 5th up. I can take two of the, there's like 5 x's here. I can take 2 of the 5 x's and move them next to the dx. So I've got the x cubed minus 5 to the 3/2. I'm leaving that alone. And then I'm going to put the x squared next to the dx. And what that does is it leaves x cubed there because there's 5 of them. So it's like I put 3 of them here and then 2 of them at the end. And now I need a 3 here. Well, that's easy to deal with. So I'm going to put a 3 inside and a 1/3 outside. Does that make sense to everybody? Okay. And in the chat, somebody's asking, we submit actual answers on WebAssign, scratch work to CrowdMark. Yes, but on CrowdMark, you should have full worked out solutions, not just like, it needs to be organized. Like you should hand in problem 1, problem 2, problem 3. And then if there's small scratch work that you don't need, to be graded, that still has to be turned in. That should be at the end of the submission. Does that make sense? So you should have like all the problems in order, neatly worked out. And then at the end, any scratch work like computation stuff that you wouldn't normally have as part of it. But anything you write during the exam has to be included. All right. Okay, so you get to here, and now this is u to the 3/2, and this part's du. This isn't u, but if I solve this for x cubed, then I can replace x cubed with what ends up being u plus 5. So if I add 5 to both sides, u plus 5 is the same as x cubed. So I can rewrite this, the x cubed as u plus 5, and then that is u to the 3/2, and I'm reserving the 3x squared dx. I'm reserving that for the du, and let's make this 3/2 a little bit neater. Okay, does that make sense? Everybody good? And I guess I should have, I'm going to go ahead and replace this with du. 3x squared dx is du. You do that at any point, but I'm going to go ahead and do it now. And now we're going to distribute the u to the 3/2. So u to the 3/2 times u to the 1st is u to the 5/2 because you add powers. And then plus 5u to the 3/2 du. Does that make sense to everybody? All right, and so now we're going to split this into 2 integrals. And the 1/3 carries to both, so we get 1/3 integral u to the 5/2 plus 5/3 integral u to the 3/2 because I'm pulling the 5 out as well. And then Nick, I see your question in chat. We'll do that next. Okay. All right. And now we use the power rule on both of those. And now we simplify. So we get 1/3 times 2/7, and then x cubed minus 5 to the 7/2 plus 5/3 times 2/5 times x cubed minus 5 to the 5/2 plus c, and then that's 2 over 21 times x cubed minus 5 to the 7 halves plus 2 over 3 because the 5's cancel times x cubed minus 5 to the 5 halves plus c. And keep in mind, WebAssign does understand math, and so either of these last two answers would be okay. You cannot leave it in terms of u, but you would not have to multiply the fractions, although it kind of kills me a little bit inside to say that. I'd like you to multiply the fraction. But for the test, if it's going to mess you up, don't. Does that make sense? Everybody clear? All right. Any questions, please ask. Don't feel bad if you don't understand something I'm doing. Please ask. The point is make sure we understand these for tomorrow.
So what you're saying is this 2 over 21, we can just leave it outside if we are worried about making a mistake?
Correct. Like if you, I mean, you could leave it as 1/3 times 2/7.
Oh, okay.
Does that make sense?
Yeah.
And actually, I guess you could probably leave that, although I wouldn't want to attempt to type that in. But like, you cannot leave u, but you don't have to simplify the fractions on WebAssign. Okay. Yeah. Other questions? Okay. All right, so somebody asked, can we do one where you have to do u sub twice? I think actually there probably aren't any where you have to do u sub twice, but it's a lot easier if you do. And so like here would be an example where I would recommend that you use u sub twice. So like, let's say I've got x squared tangent okay, x squared tangent of x cubed dx. And just real quick, in the chat, somebody's asking about this integral, the cube root of t times the natural log of t. If you're seeing that in an old test, that's integration by parts as well, which is something you're not even supposed to know that that's integration by parts, but that's something we have not learned yet for this test. So that would show up on the next test. No problem at all. Sorry, some semesters we get farther, like the exam, if the college had said when the exam was going to be, it probably would have been next week, so we would have been farther along. This is a better cutoff for the exam, which is why we're having it earlier. But okay, let's say we have this problem. So I think everybody at this point probably should automatically be thinking, hey, let's do this. Because I can automatically u sub out this x cubed. Does everybody see that? Like, I think most of us would do that. And so then we would get, okay, tangent of x cubed times x squared dx, and then 3 here and 1/3 out here. And so we get 1/3 integral tangent u du. Does that make sense to everybody? Okay, now the problem is that we don't have a formula for the integral of tangent u. That's not a basic form. And so we have to actually do the integral of tangent u. And it's important the answer is not secant squared. The derivative of tangent is secant squared, not the other way around. And so the way you do this is you rewrite tangent as sine over cosine. So you make it sine of u over cosine of u du. And now you need u substitution again. And so we choose a different letter. We use the letter v, or you can use whatever letter you want, as long as we haven't used it yet in the problem. We're going to say v is cosine u, because we're going to try to get it to be 1 over u du. And you cannot do v as sine of u because the du is not over here. Yeah. No, you're saying in chat du is 3x squared dx? Oh, my fault. I see what you're saying. Okay, that should be a u, not an x, but then I continued if that was it. Thank you. Sorry, you're for sure right. I just didn't quite know what you meant. Okay, so v is cosine u, dv is negative sine u, du. And so now we're going to put the sine u next to the du. and multiply by -1 inside, which means we're going to multiply by -1 outside. Does that make sense to everybody? All right, and so now we've got -1/3 integral 1 over v dv, and that's -1/3 absolute value of v plus c. And now we got to go back and substitute twice. So the v is cosine u, so we get -1/3 absolute value cosine of u plus c, but then u was x cubed, so it's -1/3 natural log absolute value cosine of x cubed plus c, and that's the answer. There's a way to go around that where you only have to do u sub once, but I think it's a lot more complicated. I think this is a lot easier. If you're going to do u sub once, you'd have to go ahead and rewrite this as sine x cubed over cosine x cubed, and then u would be cosine of x cubed. So it's easier to do this using u sub twice. And Nick, is that what you meant? Something like that?
Yeah, that's what I meant.
Okay, cool. All right, any questions on that problem? All right. All right, other questions? You can unmute yourself or you can put something in chat. The most recent one in chat is an integration by parts problem, so we won't do that one. That won't be on your exam. It will be on exam 2. We can do it next time. Questions? How long should that problem take us at the exam? Ooh, I don't know. Not as long as what I just took, probably. 5 minutes at most.
And will there be double U substitution on the exam, or was this more
Could
like?
be.
Okay.
Yeah, that's fair game. Like,
Okay.
not every integral will be the hardest that we've seen, but there will be some challenging integrals. Does that make sense? Okay. So like when I'm saying, don't freak out, because what sometimes happens at review sessions, which makes perfect sense, is people ask the hardest stuff, which is fair because that's the hardest stuff. And the hardest stuff does show up, but the exam is not only the hardest stuff. Does that make sense?
Yeah.
All right. All right, cool. Yes, let's do this one. Okay. So several questions in chat. Colin's asking, do we need to know double angle formulas and trig identities? Trig identities, yes, are prerequisite material. And because it's open note, I would find a good sheet and print it out or copy it down and have that available. Okay. You probably won't be using a ton with the trig identities, but that is something you're supposed to know from beforehand. So yeah. And then, man, I'm getting a ton in chat. Okay, so tangent log x to the 6 is the next problem. Harder volume is going to be the third problem. Do we need to know how to graph tangent? I can't think of a case where you need to know that on this exam, but in general, yes, you're supposed to know that. Oh man, unless there's a weird version of the problem where tangents graphed as part of volume. It's fair game. I doubt it, but it's fair game. And then, okay, if I have time, I will get these next 3 questions. So I think we will have time. So let's do this one first, just because that's the first one that came up in chat. Tangent of log x to the 6th over x dx. And Andy, because you typed that in chat, is that correct? Is this what you're meaning? I think Andy's the one that typed that in chat. Is that right? All right, I think that's right. So the first thing you should probably do here is bring the 6 out of the log. So that's the power rule for logs, that if you have x to a power inside of a log, you can bring the power down and make it multiplication, but it's still within tangent. That makes it a lot easier to do a u sub because u equals 6 log x. And du is then 6 times 1 over x dx. And I can get this by splitting off 1 over x. And now I need a 6 inside and a 1/6 outside. So there's the du. And so we get to 1/6 tangent of u du. Does that make sense? Integral tangent of u du. Everybody good? Okay, and now the rest of that you should show, but it's exactly the same as what we do here, except instead of 1/3, it's 1/6. So my bad. I'm going to jump and go to there. And so we've got negative 1/3 log, I'm actually going to go to there, log absolute value cosine u plus c, but you should show those steps because that's not a basic form that we've got. And so then that's negative 1/6, my fault. That's then negative 1/6 log absolute value cosine of 6 log x plus c. Does that make sense? Okay. Okay, so we've got several questions about area and volume in the chat. So let me kind of address those together with one good example. Why is it negative, Colin? Back up here, because on the u sub du was negative sign, so you had to get a negative in here and a negative out here. Does that make sense? Okay, all right, cool.
I have one quick question about the tangent problem.
Yeah.
How are you able to bring the 6 out of the ln on the inside of the tangent?
Because of it's just something you're forgetting from like college algebra, pre-calc, or something. This property of logs. Like when you have.
I know how you can bring it. I get that you can bring it down, but how can you bring it from the outside of, or bring it outside of the tangent?
For sure cannot. I dropped it.
Oh, okay. All right.
That's my fault because I was going too fast. That was still there, but now it's part of you here. And
all right. Okay. I thought you
came from the 1/6. I understand.
Yeah, that makes sense. Okay. Thank you.
My fault. Sorry. Yeah. Everybody clear? That's actually important. This 6 did not come from the tangent. This 6 is because I put 1/6 out here. That 6 should have still been there, and I dropped it. That's my fault. Sorry. Okay. And so, but 6 log x, that's u, which is why it didn't affect my actual answer, but it should have. This 6 should have been there. Sorry about that. All right. Other questions on this? Okay. All right. So there's several questions about volume. One is, can we do a harder one like some of the stuff we covered recently, like probably cross sections? Another is, can we do one with the slicing method? And then another is, how do we choose X or Y? So, okay, I'm going to try to cover all of that within one question. And then I know that Charlotte asked an integral, and Charlotte, I will try to do that after the volume question, okay? So let's, first of all, do this region. So let's say, consider the region bounded by y equals, let's do 12 minus x squared and y equals 4. Okay, so when you draw the region, you should get as good of a picture as possible before worrying about the area problem that you're talking about or the volume problem you're talking about. Like, we shouldn't be worrying about what the actual volume we're trying to find is. We should just draw the region. And so 12 minus x squared is basically like this. And y equals 4 is a horizontal line. And my picture is purposely not to scale, but this is 4 and that's 12. Does that make sense to everybody? All right, and then we want to find the intersection points. So here we would set 12 minus x squared equal to 4. Oh, my bad. I'm going to cheat and make this 2x squared. Sorry. Still, the graph's basically the same. And so we're going to do 12 minus 2x squared equals 4. When you take the test, please do not throw in numbers to the questions. Okay. go with the questions we actually give you. All right. But all right, so we get this, and now we're going to subtract the 12 over and divide by -2. And we get x is plus or minus 2 because we take the square root of both sides. Does that make sense? All right. And so then this is the point 2, 4. This is the point -2, 4. And so all of that should be done without worrying about the volume we're actually trying to figure out. We should draw the region. We should find all of the boundary points. So like the far left, the far right, the bottom, and the top. And so you want to make sure we know all of those values. And we should figure out what Faisal's asking in chat. How do we know whether to make the equations in terms of x and y? So we should pick a rectangle. And so the way I think of that, the way I would recommend thinking of that is if you like look at a different region. So if I have this region that looks like this, then you're looking at two possibilities for rectangles. You're thinking of a rectangle that I would describe as a vertical rectangle where the base is dx that could either go like this or could be over here or could be over here. Now, what you would like is no matter where you draw the rectangle in the region, you would like the top and bottom, the top to be the same for all of them and the bottom to be the same for all of them. Well, here, is that the case? Is the top the same for all three rectangles? It's not. It is for these two. It's on the line, but this one's different. And so we would like to avoid that. Does that make sense to everybody? Okay, so the top is different depending on where you are in the region. The bottom is the same everywhere, so that's good, but the top's different. So then if we can avoid that by going left to right instead, then we want to avoid that. So if I go left to right, if I draw that up here, if I draw that here, if I draw that way down here, are the left and right boundaries the same? So we want all the left boundaries to be on the same curve. Are they? Yeah, they're all on the parabola. We want the right boundary to be on the same curve, and they are. So in this problem, we would prefer a rectangle that goes left to right. We think of it as a horizontal rectangle. Does that make sense? Okay, that means the base is dy on this rectangle. On the diagram we're actually doing, on the problem we're actually doing, it doesn't matter. You could use up and down or left to right. Normally, I would default to up and down if there's no real preference. So here, there's no real preference. The left would be the parabola, the right would be the parabola. Here, the top is the parabola, the bottom is the line. That's, both of those are fine. So we're going to go with dx. And then, okay, the question in the chat was, how do you know whether you make the equations in terms of x or y? Based on this. If it's dx, you should solve for y and get everything in terms of x. Does that make sense to everybody? So if it's dx, solve everything for y. If it's dy, solve everything for x. Does everybody follow that? I think Faisal's the name of the person who asked that in chat. Does everybody, does that answer your question, Faisal, on that? Okay.
Yes, it does.
Okay. All right. Yeah, no problem. Okay. So on our problem, we're going to stick with solving everything for y. And so we're going to have, okay, this is y equals 12 minus 2x squared. And this is y equals 4. Okay, so then a couple other questions that were asked about area volume is, could we do one with slicing? And then could we do one more like we were doing yesterday where it's the more advanced volume stuff? So, okay, let's do some of both. So let's set up integrals. For the volume when the region is revolved, and you know the wording's a little more involved. Look at the old test for the exact wording of this, but when revolved about, and so let's say number one is y equals 3, and number 2, let's say, is x equals 7. And so y equals 3 is a horizontal line under the region, probably not quite this far, but it's out of the way. And so then we're looking for big R and small r because we think, okay, this is perpendicular to this, which is not mathematically correct, but we think, okay, vertical line, horizontal or vertical rectangle, horizontal line, that's perpendicular. So we do the disk washer method. So we look for big R and small r. Big R is the distance from the farther end to the line. So that's 12 minus x squared minus, or 12 minus 2x squared minus 3. And small r is the distance from the closer end of the rectangle to the line. Well, that's 4 minus 3. Then volume is pi times the integral big R squared minus little r squared times dx. And now we're going to add it for all the x's in the region, which go from -2 to 2. Any questions on that? Everybody good? Okay. So x equals 7 is a vertical line to the right of the region. That's now the shell method. So we get r and h. R is the distance from the rectangle to the line. That's a horizontal distance. So we take the right x minus the left x. That's 7 minus x. H of x is the height of the rectangle. So we take the top y minus the bottom y. The top y is 12 minus 2x squared. The bottom y is 4. So we get that. The volume then is 2 pi integral r times h. And that's from -2 to 2. Okay, any questions on that?
Can you go over one more time how you got Rx on number 2?
Sure. So r of x on number 2 is, when we're talking about the shell method, it's the distance from the line you're revolving around to the rectangle itself. So we're looking for the distance from here to here. In this problem, that's a horizontal distance. The way you do horizontal distances is you take the x on the right minus the x on the left. The x on the right is 7. The x on the left is just x, because if you were to like plug it in here, that's giving you y, not x. So then it's just 7 minus x. If it was like 30, it'd be 30 minus x. If it was over here, so if it was like x equals -5, it'd be x minus -5. Does that make sense?
Yeah.
Okay. All right. Other questions?
Wait, so when you're doing the R of X and
On
you said,
problem 2?
yeah, for problem 2,
Yeah.
and you said it's 7 minus X, are you doing like the X is the X, like this middle ground? And then you said, like, if it was -5, you would also have to subtract -5?
Yeah, so, okay, if for the problem x equals 7, it's 7 minus x, because it's the x on the right minus the x on the left. If it was instead, if it was a separate problem where it was x equals -5, if we're revolving, instead of revolving about x equals 7, we're revolving about x equals -5, now it would be the distance from here to here. And so it's the right x minus the left x. Well, now the x is on the right. So it's x minus -5, not -5 minus x.
Oh, okay.
Does that
Thank
make
you.
sense?
Yeah, that
Okay.
makes sense.
Okay, cool. Other questions? Okay, so this is the disk washer method, which is an example of slicing. The second one is the shell method. Okay, so I'm looking. Somebody said, Rachel, I think you said, where did I get 7 minus x? So that's where we got that. So that would be the final answer. And then what about x equals 2? Okay, so it depends on what the question asks. If we're asking you to just set up the integral, this would be the final answer. And this is the type of problem I'm talking about way back up here, where this is the way you would enter that in. Does that make sense to everybody? Okay, and so this is that type of problem. There will be a few problems that say, find the volume. And so then you would have to evaluate this. But the integrals on those should be a little less tedious on the algebra here. Does that make sense? Okay, so this is the final answer if it's just set up. If it's x equals 2, so if it's x equals 2 instead, it goes right here. And that's okay. This would still be 2 minus x. And just at that one x value, you would get an answer of 0. But for any other x value, you get what it would make sense. And then 0 would make sense there because there's no distance. Does that make sense? Does that answer the question? Okay. Okay. Any other questions on these two? Good. If somebody said something in chat about these two that I missed, maybe unmute yourself and tell me, but I think I got everything. Okay. Nick asked, did I share the document with all the graphs on it? I believe so, but I'll try to check that this afternoon. I think it's in graphing review. I know what you're talking about. I didn't say that. Yeah, what's your question?
So can the integral of tangent x like always be the negative natural log of the absolute value of cosine of x plus
For
0?
sure is that, but that's one that we don't take at face value, so you should be showing how to get it.
Okay.
Does that make sense?
Yeah. Are there times when it won't equal that?
No.
Okay.
No, it's just that we did not. It's not like the immediate reverse of one of the derivative rules from Calc 1.
Right.
You know what I mean? So like you're supposed to show your work.
Okay.
It's just, like now if this problem is on the test and you have this copied down on your notes, great, but you should not jump from here to here. Does that make sense? So same idea with tangent.
Yeah,
like,
that's fine.
all right, sorry. I know that's annoying, but
No, it's okay. Thank you.
You should show the work on
That was
that.
my question.
No problem. That's
All
fair. All right. All right, let's do, somebody said, can we do one of the harder ones, like if it's cross section? So let's do that. The advanced volume question. Okay, Faisal, if we have time, we will get to that. Somebody's got an integral first, and we'll try to do one using dy if we have time. If we don't, we will do that tonight for sure. Okay. Okay, so let's say instead of revolving around, I'm trying to erase, oh well. Let's see if I can erase that. There we go. All right, let me erase this stuff. Okay, so instead of volume when we're revolving about something, let's say we were doing one where it's like the cross-section thing again. All right, so we're gonna set up an integral for the volume of the solid whose base is this region. And cross sections parallel to the y-axis are triangles with base triple triple the height. And I should probably specify the bases in x, y. Okay, so we're gonna set up an integral for the volume of the solid where the base is this region But then they're cross sections like the ones we were looking at on yesterday's video. So if you haven't watched that one, go watch that one. It's called More Volume. It's not very long. It's like 20 minutes, maybe a half hour. But it's posted on YouTube. But anyway, there's some really good diagrams in there where it shows like a triangle coming up out of, I think really good, Hope. A triangle coming up out of this. And so like this is the bottom of the triangle and the triangle comes up out of that. Does that make sense? Okay, and so what we're gonna do with something like that is we're gonna say, okay, the volume is the integral of the area of the cross section times the thickness of the cross section, which is dx. We know this is dx because it's saying parallel to the y-axis. If it said perpendicular to the y-axis, we would need to do a horizontal rectangle, and that would actually dictate that in this case. And so that handout with more volume has some problems like that. So it's parallel to that. Now, the bottom of the triangle is this. So that's the bottom of the triangle, but then that base is triple the height, so it's not very tall. And if this is the base, this is the height, and the area of a triangle is 1/2 base times height. Well, but the height, the base is triple the height, so the height is 1/3 of the base. So we can, oops, 1/2 base times 1/3 base. So the height is 1/3 of the base because the base is triple the height. Does that make sense to everybody? It's clear, so we can replace the height with 1/3 d, which means the area is really 1/6 b squared in this case. And so b is the height of the rectangle. Well, that's the top y minus the bottom y. So the top y is 12 minus 2x squared. The bottom y is 4, which gets us 8 minus 2x squared. So then the volume is 1/6 integral 8 minus 2x squared dx from -2 to 2. And so this is an example where it's by slicing, but we're getting that 1/2 base squared by dealing with that triangle in the description of the problem. That was quick. Does that make sense to everybody? Questions on that? It's okay if the question is, I don't know what you just did. Okay. Everybody follows it? Okay. Okay. So there's an integral in the chat that I want to work for sure. Yeah. So Alex, I would probably not factor. I'd multiply that out. So yeah, this is the setup, and then you just like FOIL it out, like distribute it through, and then separate it out. Yeah, and then you just evaluate there from there. Okay, somebody asked for an integral, and then if we have time, we're going to do dy. We've got a little more than 10 minutes, so I don't know if we're going to get to dy, Faisal, but I will do a dy one tonight for sure, and then there's definitely some examples on the old exams. Okay, the integral in there, the base of the triangle, always the height of the rectangle. Brianna, probably not. It depends on how this is described, but in most straightforward examples, yes. Sorry, that's not a great answer. Okay, thanks, Faisal. I think we're not gonna have time to do both. Okay, so my bad. I'm trying to scroll up in the chat and I'm doing it on my iPad. All right, the integral that somebody asked is way up here. Where is it? Here it is. Okay. Integral from 0 to pi over 2 of sine cubed x cosine x. And the person who asked this is named Charlotte. Is this what you were trying to type? I think it is. Okay, awesome. All right, so there are two ways to go about this as far as showing the notation. What I would recommend is that you do the antiderivative on the side. So like, actually, let's do all the work in red. So that's the problem. I would come over to the side and do the antiderivative. So I'd say, okay, let's do this without those bounds on it. and make it sine cubed x cosine x dx. And this is a u substitution. So u is going to have to equal sine. Not true, it could be cosine. It's easier if u is sine. And du is then cosine x dx. So we've already got it where that's du. And so this is u to the third du without rearranging anything. Does that make sense? Everybody good? Okay, so then the antiderivative of that is 1/4 u to the fourth plus c, which gets us 1/4 sine to the fourth x plus c. And so then what I would do is over here, now say, okay, well, that's 1/4 sine to the fourth x, and I choose for c to be 0, evaluated from 0 to pi over 2. Everybody follow that? That was good. Okay, so then we're going to plug in pi over 2 and plug in 0 and subtract. And remember that sine to the fourth means that you do that. And we need to remember from trig that sine of pi over 2 is 1 and sine of 0 is 0. So then we get 1/4 for that interval. Does everybody follow that? Any questions on that? Okay, no problem.
I have a question.
Sure, what's up, Dominic?
For a formula sheet, would you allow a unit circle or no?
Yep.
Okay.
Yep. Anything you guys want on paper is fine. Just the only thing I would warn you guys about is that you need to be organized, because you should have if this was a normal test that was closed note, closed book, 90 minutes is for sure enough time. But if you're sifting through hundreds of pages of notes while you're doing the problems, that's going to add to your time. And so just be careful. So yes, you are welcome to have the unit circle, you're welcome to have all these formulas, and you're welcome to have worked out examples. Just be able to access things quickly. I don't want to freak you out. I just don't want you to spend 10 minutes looking up something on here. Does that make sense? Okay. All right, other questions? I guess we could do a dy region. That's what somebody was asking. So let's do that. Faisal, we will have time. So, all right, so let's at least get the region set up. Let's consider, man, let's find one that is tough real quick. Or, well, I'll find the one from this summer. Let's see, I think that one's probably pretty challenging. There, shoot. Okay. Here's one. I don't know if this is that hard, but this is one that was on an exam recently. All right, so consider the region bounded by those curves. So because of time, I'm going to go ahead and do that. I would, when I'm graphing this, I would solve for x. And the reason I would do that is because y is squared and x is to the first. So I'd think of that as negative y squared plus 24. We talk about in that graphing review, negative y squared is a parabola that opens to the left, and the plus 24 shifts it to the right 24. And so it looks about like that. Man, that's not a very good parabola. It looks about like this, hopefully. That's better. And then this one I'm going to think of as x equals y squared plus 6. And then that's going to look about like this, and they're going to intersect twice. and it's probably symmetric, so my picture's not perfect, but this is one where we should quickly decide dy is better. And we should set it up that way. Does that make sense? Oh man, Colin, and now I just saw your question. That's going to be the one that has to push to tonight. Trig identities. All right. Okay, so then to find the intersection points, we set y squared plus 6 equal to negative y squared plus 24. And so I'm going to add the y squared to both sides. So y squared is 9, y is then plus or minus 3. So this is y is positive 3, this is y is negative 3. And so then if I plug that into either one, I get 9 plus 6, so 15 and 15. And then, so we've got the bottom and the top. We also want the left and the right. This is pretty clearly 6, and this is pretty clearly 24. So there's a relatively complicated dy region. Maybe not the hardest one ever, but does that make sense? All right. And so now you can revolve that about whatever you want, but because it's dy, we should then definitely use these labels. So x equals not y equals, so x equals negative y squared plus 24, and x equals y squared plus 6 here. And this is the x-axis, this is the y-axis. Okay, so then if I'm going to revolve about, let's say x equals 2, and about y equals 8. So we'll do these real fast. So x equals 2 is a vertical line to the left of the region. So that's here. That's the disk washer method because it's perpendicular. So we take the farther end of the rectangle to the line. That's the right x minus the left x. But in terms of y, the right x is negative y squared plus 24. The left x is 2. Small r is the distance from the closer end to the line. So that's y squared plus 6 minus, again, 2, which is y squared plus 4. And so we get pi integral big R squared minus little r squared dy. And for all the y's in the region. So those go from -3 to +3. I know I'm going fast because I'm trying to get us finished by 1:30, but does everybody follow that? Good. Okay, and then y equals 8. We'll do that in purple. That is up here. So we're going to have an R and an H. R is then not y equals 3, y equals 8. R is 8 minus y. H is the height of the rectangle, but that's sideways. So it's the right x minus the left x. So that's negative y squared plus 24 minus y squared plus 6, which simplifies to negative 2y squared plus 18. So we get 2 pi integral 8 minus y times negative 2y squared plus 18 dy, and that's also from -3 to 3. All right, and I think the only question I didn't get to in chat, I'm sorry, Colin, is can we get to an integral that involves trig identities? The tangent one technically did involve a trig identity, but it's pretty straightforward. We can do some more complicated ones tonight. See if you can find one, and if you can come to the review tonight, we will do that. If not, I'm sure somebody will ask one, or I'll try to find one, and then I will record that and post it as soon as it's available. It's been pretty quick on the processing for the past few days, so hopefully it will continue that way. I'll be able to get this up this afternoon, and then tonight's video I'll get up as soon as I can get it up. Hopefully tonight, but it might be tomorrow morning before I can do that. All right, thanks you guys for coming. If you have last minute, just kind of informal questions, you can stick around and ask them. If not, good luck on the test. I hope to see you tonight at the review.